Our kidneys are king when it comes to regulating fluid levels. This makes a lot of sense since this is what we're going to be using to get rid of excess fluids. Or if we aren't getting enough fluid in, we know that we're not going to produce nearly as much urine. So we're going to hold on to as much of that water that we need as much as we possibly can. So we're going to try and concentrate our urine that way. Now, because of this, our kidneys are also really, really important when it comes to regulating blood pressure. Because if you have more water in your blood, so you thus have more blood volume, that means you're also going to have more blood pressure. So because of this, our kidneys are really the best place that we have for maintaining blood pressure. Now, one of the chemical pathways for maintaining blood pressure, or at least raising blood pressure, is what we're going to call the renin-angiotensin system. It's called renin-angiotensin because it's going to rely on these particular chemicals, where we're going to have renin, and this is going to deal with angiotensinogen, angiotensin 1, and then finally angiotensin 2, which is our active hormone, which is going to cause several effects. So say we have low blood pressure. We've lost blood pressure due to something. It could be sympathetic division of stimulation, or it could just be that we have just low blood pressure because we have low blood volume. Well, if that's the case, what we're going to do is we're going to have some cells that are going to sense that. The cells that are going to sense that are going to be our juxtaglomerular apparatus cells, that JG apparatus, which remember is kind of out here in between the efferent and afferent arterioles from the glomerulus. Now, these will then sense that we are running low on blood volume, or we are running low on blood pressure, at which point the control center here is going to say, hey, we need to release some renin. So the renin is going to get released into the blood. Now, renin is a chemical that is going to activate this chemical that is going to be moving through the blood all the time called angiotensinogen. Now, remember that ogen means to make. So that means this one is going to make angiotensin. So renin activates angiotensinogen, and it turns into a chemical called angiotensin 1, which is still inactive. The next enzyme in line is going to be our ACE enzymes. Now, ACE, or ACE, stands for angiotensinogen converting enzyme. Its job is going to be to convert angiotensin 1 into angiotensin 2. So an ACE inhibitor would basically be a chemical that would stop this conversion of angiotensin 1 to angiotensin 2. People are on ACE inhibitors because angiotensin 2 causes several things, all of which are going to lead to higher blood pressure. So let's look at some of the effects of angiotensin 2. The first thing we're going to do is it's going to cause vasoconstriction of our blood vessels. So your blood vessels, or your arteries, are going to constrict a little bit, putting additional pressure onto the blood. So this is going to create additional resistance. Creating additional resistance, we know that that is going to cause an increase in blood pressure. Now, that increase in blood pressure is also going to cause a decreased glomerular filtration rate. So we're actually going to shut off the kidneys a little bit. So we're going to decrease how much filtration we're actually doing, which means we're going to stop producing as much urine filtrate. We do this so that we can maintain blood volume. By maintaining blood volume, all of a sudden we're maintaining a higher blood volume, so we're not losing as much fluid, so we're able to keep that blood pressure high. We're also going to tell our thirst center to, well, be thirsty. So basically, our hypothalamus will start to send out a signal that says, hey, we need to take in more fluid. Well, more fluid means we're raising blood volume even more, which means we're raising blood pressure even more. Our ADH will secrete, our posterior pituitary is going to secrete antidiuretic hormone, ADH. Anti meaning don't, diuresis meaning get rid of water. So antidiuretic hormone basically, once again, tells the kidneys to hold on to more water. So maintaining blood volume, which is raising blood pressure, at least maintaining blood pressure. And then finally, we can also cause release of aldosterone from the adrenal glands, which is also going to decrease urine output, which helps us maintain blood volume and maintain blood pressure. So because of this, we can see this kind of pathway between renin, angiotensin 1, angiotensin 2, where angiotensin 2 causes all of these things, where each of these would cause at least maintaining blood pressure at a higher level, or even raising the blood pressure. And we're doing these all at the same time. So this is why if someone has, say, too much ACE enzyme, or we're seeing too much of this process, why you can have elevated blood pressures, because, hey, we're seeing a little bit too much vasoconstriction all the time. We're seeing a little bit too low of a glomerular filtration rate. We're not drinking enough water. All of these things are going to lead to kind of increased blood pressure. So if we wanted to stop all of these things that lead to increased blood pressure, so say we wanted to bring someone's blood pressure down, we can inhibit the activation of this hormone.